Dame y gospodo, ladies and gentlemen, thank you very much. I'm really sorry I cannot be with you today physically. Um, however, I will still talk about some very interesting topics: microservices, APIs, cloud, and Java EE. Uh, let me start. Let me start this discussion with microservices. Uh, Microservices have become an important topic. This figure shows the Google Trends. You can see that beginning with 2014, microservices have become more and more important and more influential on how software has been developed. Now, what are the microservices? Let me start with with a simple definition of the microservice architecture. Now, microservice architecture is an architectural approach which emphasizing decomposition of applications, decomposition into single-purpose, loosely coupled services, managed by cross-functional teams for delivering and maintaining complex software systems with the velocity and quality required by today's digital business. Now, although this might not sound very interesting, it very well summarizes why microservices are important. However, let's be a little more practical. Now, let us have a look at the classical application. This is a very simplified architectural view of a multi-tier application, which consists here in the green color of the web front end, of the user in whatever technology. Then the backend, the business logic. In this simplified example, we have 5 services: product catalog, shopping cart, purchase, payment, delivery, and in the back end we have the database management system. Now, doing this traditionally, either in Java EE context or using some other technologies, we would peg this application as a whole and deploy it on in Java world on a Java EE application server, in some other technologies on some other application server or deployment technology, doesn't matter. So in Java world, we would basically deploy the solution to an application server using a monolithic approach. What does this mean? We would peg this in a single var or ER and deploy everything as a whole to the application server. Now, using this approach, and this is a very well-known approach, I'm pretty sure some of you or many of you are developing apps in this way today. However, using this approach, there are certain problems. One of the problems is scaling. If we deploy such an application on an app server as a monolith, then we can scale this application only as a whole. However, if I go back on the previous slide, I could argue that not all the services in this application are used the same when this application is actually deployed. Probably the most used service would be the product catalog. I would guess that 10 times more users would browse the catalog than those who would actually do a purchase or payment and so on. So what I'm trying to say is that in modern web applications, having those applications packed as monolithic solutions reduces the flexibility for scaling, because the fact is that not all parts of the applications need to scale the same way, and this is the fact for the majority of applications. Scaling, however, is not the only aspect. Now, if we do Java EE development in the monolithic way, a very well-known problem is also how to upgrade versions. If we would like to update the purchase service, for example, we would need to redeploy the whole application. And a little bit different aspect, what if we would like to upgrade the technologies? For example, we are using Java EE6 and we would like to go to Java EE7, or we are using Java Standard Edition 7 and we would like to go to Java Standard Edition 8. With the monolithic approach, we need to upgrade the whole application server. So this means the whole application, or even all the applications that are deployed on the app server. What about the microservice approach? Now, if we would do this same application in the microservice approach, we would basically package and deploy each individual service separately. So instead of having one big backend ER or var, we would pack and deploy each service separately into its own runtime. Now, if we look at the benefits of such approach, what could we see? We could see that this way, well, we can just go through the same disadvantages that we mentioned before. Let's have a look at scaling. If we would package each service separately, individually, we could scale this application also individually. So we could have 10 instances of product catalog, but only 3 or 4 instances of shopping cart. So basically, we could scale each individual service exactly in a way that the users who are using our application expect to achieve the optimal performance. Using the microservice approach also simplifies upgrades of the parts of the application. Now, if we would like to upgrade the payment service, we could do this without the need of deploying the whole application. We could also select the versions of technologies. For example, we could develop the payment using Java Enterprise Edition 7 and Standard Edition 8. However, have the other services still in the older versions. Even more, using microservices in such a way gives us a future-proof approach. Now, imagine that you wouldn't want to use Java for the whole application. For example, for the delivery service, you will prefer to use Node.js or whatever other language or technology. With microservice approach, this is possible. Now, microservice architecture brings us some benefits, and looking at this architecture where each individual service, each individual microservice, it's an individual, self-contained, individually deployed process, brings us a very flexible architecture. It also brings us simplifications in the development process, because each team can develop its own microservice separately and there are less dependencies. If we look at the reuse, at the service reuse, not the source code reuse, if we look at the service reuse, you probably remember that reuse and consolidation of functionality has been one of the objectives of many architectures, for example, service-oriented architecture. So we could argue that microservices also foster foster reuse and make it easier to achieve in real world. I have already mentioned upgrades. I have already mentioned scaling. However, if we do the microservice approach, we should also be aware that there are several principles which we should follow. Each microservice should follow the single responsibility principle. So microservices should be small pieces of software doing one thing, but it is very important that they do this thing very well. And this goes in line with the sentence from Doug McElroy, who many years ago said that we should write programs that do one thing and do it well, and that we should write programs that work together. And microservices actually are very in line with those two sentences. What else is important? Microservices should have well-defined interfaces. Those interfaces should be explicitly published and defined following the patterns and best practices for service interface design. There are many best practices and patterns. I cannot name all of them today here in this presentation. Microservices should also be integrated. Actually, microservices need to be integrated. If we look back at this figure, we can see that an application actually consists of many microservices, and those microservices communicate among each other using those interfaces which I have mentioned, and these microservices together form an application. Now, integration of microservices should follow loosely coupled approaches. This means either synchronous or asynchronous integration. And I would also advise you, if you will become interested in microservice development, that you read something about circuit breakers, which define how basically you can separate existing applications and which practices to use to limit the communication between the microservices. And then maybe the final principle which I will mention today is design for failure. If you imagine an application which consists of several microservices, it is very important that those microservices actually work. And to make sure that microservices work, it is important that they can handle some unexpected situations and that the fault tolerance becomes a requirement in the development cycle. If we go on and look at the deployment and execution and so on, so the fact is that we deploy each microservice separately. A microservice then executes its own process. This could be a virtual machine, this could be a container. I will come back to this later on. But there are several interesting situations. Then, for example, a microservice can have multiple versions, which all can be deployed side by side, and they are also executing side by side. So you can have a version 1, version 2, version 3 for microservice. So it becomes important that an application can actually deal with versions and can select the right versions of a microservice to function. And as already mentioned, but let me emphasize once more, doing it this way, having microservices stateless, it allows us to scale them horizontally and also independently. Now, this slide tries to summarize those concepts. Now, if we look at the application, which consists of several functionalities, means several services, we have here, on one hand, we have modularity at the development time, which means how we organize modules in the integrated development environment tool and so on. Then we have the communication between the services, which has been defined by the service orientation, SOA, service-oriented architecture. And finally, we have microservices, which makes services independent building blocks of an application. Now, microservices also have their own disadvantages. We have many small microservices. As mentioned, they are deployed independently. There is complex dependency management, which is why automation is very important. Today, there is an unwritten rule that using microservices actually requires that you have DevOps procedures set up. What I'm talking about is continuous integration, continuous deployment, and automated testing. Without those tools, real-world microservice development is actually not possible. What else is important? Testing, logging, monitoring, they all require new tools which support microservices. Now, if we look specifically at Java Enterprise Edition, we have another problem. This is a problem of the fat application server. Now, if we would need to have a whole application server in each process where a microservice would execute, then this would basically this would be a disadvantage and would make things even more complex and somehow even deny the concept of microservices. Therefore, in the last year, we have seen a lot of development in this area. There are actually two ways. One is the serverless Java EE. The serverless approach to Java EE goes into the direction that you package and deploy your Java EE applications into fed jars and that you execute them on the Java Standard Edition runtime only. So you don't need a Java EE application server. What I will show you is a framework called Kumuluz EE, which is the first microservice framework for Java EE and supports all the standard APIs and allows you to build microservices in such a way that you use Java EE APIs, but still package them into jars and execute them on the standard edition. And then there is a similar framework for the Spring framework. It is called Spring Boot. Now the other approach are the slim application servers. So application servers reduced to only those technologies that your microservice uses, and therefore they have considerably reduced footprint. Wildfly Swarm and Pajara Micro are the two examples which are most well known. In this context, let me also mention the micro profile. This has been announced on this year's Java 1, so not even a month ago. And the micro profile is a baseline platform that defines the microservice architecture for the enterprise Java and also delivers portability across multiple micro profile runtimes. So the initial configuration of micro profile is JAX RS. This means REST services, context and dependency injection, and JSON processing. Now, what I would like to show you today, just to give you some concrete example, is the Kumuluz EE framework. This is the open source framework. It can be freely downloaded. You can also find it on GitHub. This is the last year's Duke Choice Award winner. As I've already mentioned, Kumuluz EE allows you to generate standalone microservices following these 12 factor principles. Google them if you are not familiar with them. Microservices are packaged with self-contained jars, and those jars include the full runtime of those technologies which you use in your application. For example, this could be JAX RS, CDI, JPA, bean validation, for example, whatever you require. Now, two most important aspects are that it generates very efficient jars, so small footprint, which means that they are ideal for virtual machines, particularly for Docker containers, which I will come back, and that you can choose the runtime. So, for example, for Servlet, you can choose a Jetty, Tomcat, Grizzly, whatever, and similarly for other technologies. Just to give you an impression, let me briefly demonstrate what I'm talking about. What you see here is IntelliJ, where I have a Java EE project open, And I hope you can see this. This is a REST service using JAX RS, standard Java JAX RS code, applicants, and then some Java code. There are some more resources defined. Now, to build such a Java EE application using Kumuluz EE, the only thing you have to do is to go to the POM XML file. This is the Maven configuration file. And I'm showing you this on a concrete example of a questionnaire application used by Slovenian government, which has now set up the Slovenian state cloud, state government cloud. But this is another topic. Let's just stick with the microservices. So you have a standard POM XML definition. And the only thing that you need to add to use Kumuluz are those dependencies. So first of all, you need to include the Kumuluz core, and then you have to include all those technologies which you are using in your application. For example, servlet support with Jetty, then Java persistence API for object relational mapping to the database, context and dependency injection, support for JAX RS for REST services, and then support for bin validation. This is basically all you need to do. So no tweaks in the code, nothing else. Now, if you go, now let me just show you how to build. So you build such a microservice with a simple Maven build, which is quite quick. And then you can run it, and this is the most interesting part. You can run it as, so a jar is generated. Let me show you. So a jar, this is a questionnaire, this is vprašalnik in our language. A jar is generated, a quite small footprint jar. And you simply run it using the Java Standard Edition runtime environment. And you would probably also notice it's already started. See, Kumuluz EE started successfully. So also the startup time is quite quick. Now, if I go to a web browser, go to the REST endpoint, I can see that this REST endpoint now works. Now, just to be sure that this is this REST endpoint, if I stop it, if I go back, doesn't work anymore, right? So let me start it once again. I have here basically another project with the front end, which consists the HTML Angular front end. And let me pack this front end in another microservice, which I would do basically the same way as previously. So the front end would then be another microservice, which I would need to run in a separate process as well. This one contains quite a lot of HTML5 and JavaScript, so building it takes a little bit longer. All right, another jar has been generated, and let me just execute this jar in the same way as previously. So now we also have the front end. Which allows us to use this application, in different ways. Okay. Not to lose too much time, let me get back to the slides. And let's continue with this discussion about microservices. Now, the next question would be where to deploy the microservices. And of course, several questions arise, such as put all the microservices in a single virtual machine, each microservice is its own virtual machine, each microservice on several virtual machines to scale it. What I'm trying to point out is, however, that the most efficient technology to deploy microservices are containers. What I'm talking about specifically are Docker containers, and I'm pretty sure that most of you are familiar with Docker containers. Docker containers, in comparison to traditional virtualization, reduce the size and the footprint of the container, and with removing several layers, which makes Docker containers very lightweight. And not only that they are lightweight, Docker containers are also very quick to start up and to shut down. This figure shows a comparison for a startup and shutdown for traditional virtual machine and Docker containers. So what I'm basically trying to say is that now imagine a world where you have your software built out of microservices. Those microservices are deployed to Docker containers, and those Docker containers are then deployed to a specific cloud or platform as a service, which basically instantiates or removes as many instances of Docker containers as needed. And we all know that Docker containers are today supported by the majority of cloud providers. Also, you probably know that Docker support has been announced on Windows Server 2016, which has been published just a few weeks ago. There is, however, also an alternative to use the Docker containers on container orchestration tools. So what I would advise you to do, if you haven't done so, to look at Kubernetes, Docker Swarm, Mesos, and other technologies, which provides you great ways to scale your Docker applications in connection to microservices. So microservices and Docker containers, we can see they are a perfect fit. And now for the final ingredients are the APIs. Now APIs are actually the interfaces. We already had this figure and we had those interfaces there, and the communication to the APIs is something which is required for the microservice architecture. However, for more complex environments, between the front end and the APIs of individual services, you will usually require some additional middleware. One of those would be the API gateway, which would handle all the communication. Then for the service, microservice API discovery, you would need a discovery, such as Zookeeper. And finally, you would need an API management system, which would allow you to manage all the APIs of different microservices. Now, you also know that APIs are considered not only as a developer technology. They have been elevated from the development technique to a business model and the driver. And APIs are also becoming the major asset of digital transformation. However, I don't have enough time to go into all those. Let me just summarize. So microservices, the microservice architecture, containers, Docker containers, and APIs, they are the key ingredients of the architecture for the cloud. And building applications that can execute in the cloud requires using those aspects. To read more about this, I would advise you to read a recent article in the Java magazine. And I'm also providing you here some useful links. At the bottom, you can find my email. So if you will have any additional questions or would like to discuss some of those aspects, please feel free to email me. Thank you very much.